All right, guys, so we're going to take a look at some applications of these trig functions that don't involve the x as being the angle of rotation. So in our previous lesson, okay, Marcus and Blair, are you guys ready? Okay, so these ones, the x is going to be something different. It might not be angle of rotation. It might be time. Usually we look at like time as part of x as well. And then the y could be different things depending on the question. So in this example, we have a sine function that is modeling the height of the rider on the Ferris wheel above the ground. But instead of the angle of rotation being modeled as x, it's time as the x. So yes, this is still a circular question, but we're not looking at angle of rotation as the x coordinate. We know we can do that because we've done examples with that, but now we're looking at time. So this one says to graph the function. One option for graphing this function, it already gives us the model for the equation. One option is I could do transformations and we could graph from that. The other option is we can sort of like intuitively do this. So certainly you guys know how to do transformations. You can start with the sine function, start with the parent function points, and then just do your transformations and graph from there. Because I've already taught you guys that, I'm going to show you like maybe a quicker method that we can use to graph something like this. So firstly, we know the amplitude of this function is 10. So we're just going to pick out some information here. If I know the k value, what does that tell me about period? How can we find period from the k? Ella? Divide is right. Divide 360 by 3. So this is 120 seconds. It takes a rider 120 seconds to get around the Ferris wheel. It might be helpful for us to also determine the max and min as well. So we can do that for part B. So if my amplitude is 10 and my midline, which is the C value, is 12, how can I find max and min if I know the middle of the graph and the amplitude? Matt? It is. So we'll do midline or the C value minus amplitude and plus amplitude to get max and min. So max is C plus amp. So we'll get 12 plus 10, which is 22 meters. And minimum C minus amplitude. We'll count down the amplitude from the C, which gives us 2. Okay, so now we know the top and bottom of our Ferris wheel. We know the middle is 12. So let's just graph over here. We'll indicate a scale going up by 2s, I think would be good. So we can get up to 22. So we know it has to go in between 2 and 22, and it has to hit 12 as the middle as well. So max, as we said, is 22. Min will be 2, and the midline is 12. What does this tell me? Ella? Matt, can you put your headphone away, please? So this tells me the rising midline, basically, right? The phase shift of sine is the location of the rising midline. So it happens 30 to the right. So I'm going to pencil in my midline, which is 12. And I know one cycle around the Ferris wheel takes 120. So perhaps maybe we can go by like, I don't know, maybe like 15s. 15, 30, 40, I think that should be good. 60, 75, 90, 105, 120. Should be good. This is time in seconds. Probably could have gone by 10s here as well. And height in meters. So we know 30 seconds to the right, we're at a rising midline. So I'm going to go at 30 seconds. I'm going to be on the midline, and I know I'm going to be like rising up into a mountain from there. I'm not sure exactly where that goes from there, but I know that that is a spot there. I'm going to add a couple more points onto here. 120 seconds after that, I'm going to be back at another rising midline. So if I took 30 and I added 120 seconds, I'm going to be back at a rising midline at 150. A cycle must start where it finishes and finishes where it starts. So we know every 120 seconds, I'm going to be back at that same location, right? Now the rest of the graph has to be perfectly equally spaced. So I think we can figure out if we know we're sort of like going into a max, oops, if we know we're sort of like going into a max from here and then going down and making a wave like this, I think we can figure out if those all have to be equally spaced where each of them are. So let's start with this point in the center here. If I'm halfway in between 30 and 150, where is that? What's exactly halfway in between 30 and 150? Okay, so that's where this point should be. Then I know that this is a rising midline, so we have to go up to a maximum. This has to happen perfectly in between 30 and 90. So where does that happen? 60. So there's my maximum up at 60 at 22. And minimum has to happen exactly in between 90 and 150. Where does that happen? 120. So that's at 2. So there's one cycle right there. I can see every 30 degrees, we have a new piece of our cycle. If I wanted to draw this from 0, I could also extend the cycle backwards like this, and we could extend and put the minimum here, like so. So I don't even think we really need this section, but it does, that little section at the end, but it does help us figure out the rest of the graph. So I can do transformations as usual. You guys know how to do that. You've practiced that. Or you can just sort of like do it intuitively. You can figure out what the period is. Everything has to be equally spaced after that. So if a full rotation takes 120 seconds, each quadrant of that, each fourth of that takes 30 seconds, right? 30, 30, 30. So that's kind of how you can figure things out from there. If this confuses you, to do this like the intuitive way and just kind of figure out where all the points are, just do transformations as usual. Ella? Yeah, I don't care. Whatever works for you. Okay, I just thought I would show you guys this one so that you can kind of see like that you can figure this out, because we know everything has to be perfectly spaced. Okay.
For the period.
What is the height of the rider above the ground after 30 seconds? We haven't answered that one yet. You'll probably look at the graph and figure it out. Ella? 12. It's right here. If I wasn't sure, I could plug in 30 in for time, and then I could just calculate, right? So if I asked you what is the height after 45 seconds, if you don't know, you're going to plug in 45 and then just calculate in your calculator. That's all you have to do. This one, we could already see it on our graph, so we didn't have to do any extra calculations. Express the equation from example number 1 as a cosine function. So I believe it was called h at t. How do we switch this into a cosine function? Sophia, to answer your question, sorry, we do 360 over 3 for the period because we calculate period by doing 360 over the k value, which is 3. So yes, how do we switch this to a cosine function? Maybe someone that hasn't answered yet, although I appreciate it. What's the one thing that needs to change if I switch from sine to cosine? Kira? We have to switch the d. So everything else can stay the same, the 10, the 3, and the 12. And how do I switch to d of cos? What would that look like? Kira, do you want to do the rest? We could do that, yeah. So we could take d of sine and do plus 90 over k. So we would take 30 and do plus 90 over 3. Or we can just look at the graph. Where does the maximum fall? Chris? X of the max, not Y of the max. 60. So this is the D of cos. So we'll say minus 60. Okay, so because I'm talking about like the D value shift, the left and right shift, I like, yes, the maximum is up at 22, but we're interested in where it is to the left or the right of the x-axis, so or y-axis. So we're looking for the x coordinate on that maximum point. Questions on this one? Matt? Hey, someone want to explain that? How do we get negative 60? Yeah, we're looking for the max. So we're looking for the x of the max to find D of cos, which happens at 60. Okay, any other questions? Matt? If you were to put what in the equation? Yeah, so you would do your initial sine value, which is 30, D of sine, minus 90 over K, which is 90 over 3. Sorry, it's plus 90 over K. And you'd get 30 plus 30, which would give you 60. So you'll get the same thing. And then we have to switch the sign when we put it in, right? So it becomes minus 60. Okay. Next, we're going to take a look. So I mentioned tide in our first lesson. We're going to take a look at the model of tide. Height of tide, T hours after midnight. It's modeled by the H at T function here. Find the max and min values. What time do they occur? What is the depth of the water at 9 a.m.? Okay, I think we can find max and min pretty easily. We have A and we have C. So if I know, we could just do like a really basic wave here. If I know the middle of the graph is at 7, if I count up the amplitude from that and down the amplitude, I should get my max and min. So what would they be? Matt? Not -2. If I count down 5 units from 7, we're just at 2, yeah. So 12 meters and 2 meters will be our max and min. Again, you can do this by just doing C plus amplitude or C minus amplitude. Okay, what time do they occur? So again, a couple options for this. We can figure out, we could just do transformations of the original sine function points and see what happens to the max and min points. We could do a general sketch and see like where those max and min points fall. So like we did in part 1, we did kind of just like a general sketch. I think it would be pretty quick if we took the base points of sine which are like 0, 90, 180, 270, 360. And then 0, 1, 0, -1, 0. That's what we talked about in transformations. And which points in the original sine function are the max and min points here? So that's really what I'm interested in, is just max and min. Ella? 1 and -1. So these are the points that I'm interested in. Let's do transformations, but just to those points. That's all I really need. So I'm going to set up my transformation equations. 1 over 30 times x plus 5, and then 5y plus 7, ay plus c. And I'm just going to do these 2 points. I'm not interested in the other ones. We don't have to create a graph here. I just want to know where the max and min get transformed to for the new max and min of our function. So 90 divided by 30 is 3, plus 5 is 8. 270 divided by 30 is 9, plus 5 is 13. 1 times 5 plus 7 is 12. -1 times 5 plus 7 is 2. Do we recognize the values 12 and 2? That's the max and min from part A. This is the time. This is the height, right? So we already knew that this was max, and we already knew that this was min. If T represents hours after midnight, what is 8 hours after midnight? 8 a.m. So the max happens at 8 a.m. What's 13 hours after midnight? One o'clock, 1 p.m. Okay, what's the period of this function? Can somebody tell me what the period is? How do we find period? Claire? Okay, so every 12 hours, the tide will return back to the same height. So if every 12 hours I hit high tide and every 12 hours I hit low tide, there should be a second time within the day that I'm going to hit a high tide and a second time within the day that I'll hit a low tide. When is the second time, if the period is 12 hours, that I will hit a high tide? Ella? Okay, so if I add 12 hours, this will also happen at 8 p.m. How about 1 p.m.? 1 a.m. So we'll add 12 hours, which is the period, and I will also have a low tide at 1 a.m. So every day at 8 a.m. and 8 p.m., I have high tide. Every day at 1 p.m. and 1 a.m., I'll have low tide. Matt. Well, if you look at your equation, this is like the x, and this function notation tells you like this inside here is x, and then height h at t, height at time, that's going to be your y. Also, like time is an independent variable. Height depends on time, right? So the independent variable is always going to be x. Okay, time does not depend on height. Height depends on what time it is, right? Okay, how do I find the depth of the water at 9 a.m.? Oh, Kira, sorry, did you have a question? So high tide is going to be like the higher water level, right? So this one is 12 meters. Like this is a higher water level than this, right? 12 meters versus 2 meters. No, that's low tide. 1 p.m. and 1 a.m. Yeah. So let's say high tide, and then this will be low tide. Josh?
You also just find high tide by doing the 5 plus 90 over
5 plus 90 over k. Yeah, that could work, because that will give you the max of coast. It's a good idea. Okay, how do I find the height of the water at 9 a.m.? Plug one in. I will plug in 9 because 9 a.m. is 9 hours after midnight. And I'm going to sub it right in for t. So we're going to evaluate h at t. Oh, h at 9, sorry. Bye, Blair. So 5 sine, get some calculators out there, make sure you're in degree mode. And then plus 7. So what do we get? Sebastian, are you calculating on your calculator? Your what? Okay. Someone other than Ella. Chris? 11.3. Kira, did you get the same? And this is in meters, right? Height at 9 a.m. will be 11.3 meters. Does that make sense if high tide is at 8 a.m.? That 9 a.m. would be about 11.3 meters. What's high tide? 12 meters. So an hour later, if the tide is about, if the height of the water is about 11.3, that probably makes sense, right? Okay, so that's good. So we're using our common sense here still, right? Okay, questions on this? Okay, last one. And then you guys will be done the course. This is the last example of the course. Look at that. Momentous occasion.
Wait, there's so like no more units after this?
No more units after this. This is the last lesson. So we have a test next week and then we'll have exam review.
For like 2 whole weeks. Just
Well, I mean, we only have 2 classes next week and then we have 3 classes the week after that. So it's not that much. Yeah. Okay. So we have a wind turbine. It has a height of 55 meters from the ground to the center of the turbine. We're going to graph one cycle of the vertical displacement of a 10-meter blade turning counterclockwise versus time in seconds. The blade starts at the maximum and takes 80 seconds to complete one full rotation. And I should have also added vertical displacement from the ground. So we're going to add that into this question. Vertical displacement from the ground. Yeah, I'll just put it down here. Okay, so I always like to just draw a picture first. We're going to draw our nice little wind turbine. Here's the rotation of the blades. This will be the center. And then it's going to be a certain number of units off the ground. This we'll just put at the top. Okay. So our blade starts at the maximum, which is here. So here's the tip of the blade. That's where it's going to start. Start is always at 0. So how much time has passed at the start? 0 seconds. So this will be the 0 second location. 0 seconds. Talk to me about heights here. What is the maximum height that we could be off the ground? Well, actually, sorry, let's talk about the center. The wind turbine has a height of 55 meters of the ground to the center. So these heights in the center, let's do that first. These are both 55, right? Colin?
I was just gonna say, if the total height's 55 and the blade's 10 meters, does that mean the center is at 45 meters?
So the wind turbine from the ground to the center, this is the center of the turbine, right? Is 55. So if the blade is 10 meters, what's the max? 65. And then if the blade is 10 meters, what's the min? If it's facing down, what's the minimum? 45. We subtract 10, right? Okay. This should be pretty easy from here, right? How many? So it takes a full 80 seconds to go all the way around. How much does each quarter take then? 20 seconds. Okay. And we're rotating counterclockwise. So if I rotate here, this takes 20 seconds. If I rotate to the next point, how many seconds? 40 seconds. So here we'll be at 40 seconds. Next point, 60 seconds. And then a full rotation back around will be 80 seconds. Okay, perfect. So I'm gonna do, let's go 10, 20, 30, 40, 50. Yeah, we'll go at 10s. This is time in seconds. This will be height in meters. Now guys, because we're only going from 45 to 55 to 65 here, I'm gonna do this little thing that we can do with graphs, which is I'm just gonna write this like so, which means essentially I'm squishing the bottom part of this axis so that we can just start at whatever value we want, as long as we're consistent with like where we start and what we're going by. So let's say from here, we'll start at 30, 35, 40, 45, 50, 55, 60, 65. Okay, that's just so that I don't have to go all the way from 0 to 30 and fit that on here, because I'm really just interested in 45, 55, and 65 as different heights, right? So the first point is 0 at 65 seconds, 0 seconds at 65, or 65 meters, sorry. Second point, as we rotate around, 20 seconds at 55. So 20, you're gonna graph that at 55. Next point, 40 seconds at a height of 45. Okay, next point, 60 seconds at a height of 55. And then the last one, 80 seconds back at a height of 65. There's our rotation of our blade. Questions? Okay, I personally think that it's easiest just to draw a picture with it. It doesn't mean you have to have the picture provided there. Like if you feel like you can figure it out without, that's fine. Yeah. So anything, are we all good? Okay.